Hello class, this is chapter 3.1 and in this video we are going to talk about the principle of superposition. This is how it goes. So remember that we have a second order homogeneous linear ODE that's always going to be written like this. And we say that this is a homogeneous equation if instead of fx we have a 0 here. Okay? This is what it means to be a homogeneous second order ODE. And the principle of superposition says if y1 and y2 are both solutions to a homogeneous second order linear ODE, then y equals c1 y1 plus c2 y2 is a solution too. For any values, constants, C1, C2. So what I'm saying is that if you have two solutions of this equation and you add them together, the sum will also be a solution. If you add them together and put weights on them, like C1 and C2, multiply them with constants, the sum will also be a solution. And it's not very hard to see why this is true. So you see that if y1 and y2 are both solutions, then let's look at what happens at y double prime plus px y prime plus qxy. Okay, so you know that y equals c1 y1 plus c2 y2, so we can just plug that in, the values of y. So we know how derivatives distribute, so this just becomes c1 y1 double prime plus c2 y2 double prime plus px c1 y1 prime plus c2 y2 prime plus qx c1y plus c2y2. Okay, because the derivative and the second derivative both distribute very nicely, we can do that. And now we can separate this out into two different expressions, one that has c1s in it and the other that has c2s in it. So this becomes c1 y1 double prime plus c1 px y1 prime plus qx, oh sorry, this should have a c1 here too, plus c1 qx, and this should have a 1 here, y1. Okay, that's the terms with all the 1s in them, and there's also a bunch of terms with just 2s in them. c2 y2 double prime plus c2 px y2 prime plus c2 qx y2, and we can factor out the c like so. c1 y1 double prime plus px y1 prime plus qx y1 plus c2 y2 double prime plus px y2 prime plus qx y2. Alright, but we also know that y1 and y2 are both solutions to that homogeneous equation. And what we mean by solutions is that this differential equation is going to equal to 0, and that differential equation is going to equal to 0 because y1 and y2 are both solutions, so we end up with just c1 times 0 plus C2 times 0 equals 0. But that implies that our y is also going to be a solution to the homogeneous equation. So you can see that this is why the principle of superposition works that way. Okay, so let's look at maybe a slightly more concrete example. And this example is just going to involve y double prime plus y equals 0. So this is a second order linear ODE, and you can see that I can offer you a couple of solutions. So one, you can check on your own that y equals cosine x is a solution. This is because y prime equals minus sine x, and y double prime is going to equal to minus cosine x. So this ends up being, let's call it solution y1, okay? So this ends up being minus cosine x plus cosine x equals 0, which certainly works. So let's try another solution, y2 equals sine x, and this gets us y2 prime equals cosine x, and y2 double prime equals minus sine x, and again, this gets us minus sine x plus sine x equals 0. So y1 and y2 are both solutions. So what happens when we try y equals c1 cosine x plus c2 sine x? And this is just what's going to happen is that we're going to get y prime equals minus c1 sine x plus c2 cosine x, and y double prime is going to equal to minus c1 cosine x minus c2 sine x. And when we plug that into the equation here, what we get is minus c1 cosine x minus c2 sine x plus c1 cosine x plus c2 sine x. And what's this going to equal to? So this cancels, and this cancels, which makes our answer 0. So it turns out that any combination of cosine and sine is also a solution to this differential equation. Yeah, that's how the principle of superposition works.